Okay, for example 10, what you actually have right now is they are telling you that 1 plus 2i is a root of this equation. So I'm not asking you to solve. Okay, I'm telling you this is a root of this equation. Your job is to find P and Q. Condition P and Q are real. Okay. So if you look at this question, can you actually pinpoint to me what topic is this actually? Something is a root to another equation. What topic is this from a secondary school? What alpha beta? What topic? Can you be more specific? Not alpha beta. Factor and remainder theorem. Number? Factor theorem. So think back into your factor theorem. If I tell you that something is a root to that equation or that function, what will happen? That means if I substitute this thing inside, that means I replace z by 1 plus 2i, you should give me 0, right? This is what you learn from a factor theorem. Make sense? Make sense? So now what you are seeing here is factor theorem in complex number. So all you need to do is to replace your z by 1 plus 2i. Thereafter what you do? Expand and regroup again. All the real part together, all the imaginary part together, like what you see here. Then real part plus imaginary part equals to 0. What's next? This must be 0. This must be 0. You will again generate two simultaneous equations for you to solve for your P and Q. Easy? Nothing fantastic, right? So it's a simple logic, but it's an extension of your factor theorem that you learn in your secondary school. Any problem? Can you understand how everything comes about? Simple? Still simple, right? Okay, now let me introduce you to something new. There's this term called the conjugate of a complex number. So what, in terms of definition, what do I mean by a conjugate of a complex number is that if a complex number is z equals to 3 plus I, the conjugate is 3 minus I. So how does conjugate happen is that you negate or you change the sign of the imaginary part. Can. So 3 plus i's conjugate is 3 minus I. So what's the conjugate of 3 minus I? 3 plus I or reverse. Okay. Okay. So all you need to remember, conjugate means change or negate the sign of the imaginary part. So how do you represent conjugate in symbol form? Symbol form is represented by your z asterisk. Sometimes you see a z bar on top, but most times in the A levels you see z asterisk. So be familiar with the symbols. Okay, because half the time they won't tell you that they won't spell out z conjugate, they will tell you z asterisk. Okay? So nothing really fantastic, just a new definition for you to remember. But what is the purpose of you learning all these conjugate is because of all these properties down here. Okay, all these properties in your page number 7, right? What page is it on your lecture notes? Page 7, correct. All in all, you have 8 properties down there. Look at the properties and look at the proof on the right hand column. Is the proof difficult? Look across all the properties. Are the proof difficult? Quite intuitive, right? Nothing really fantastic. So do you need to remember all the properties? Or are you capable of proving it on the spot? So it's back to you, your choice. Okay, most people will not bother to remember, or most people after a while all these things become intuitive. But among all the properties, I want you to highlight 2 very important ones. Number 2 and number 3. Okay, these are the 2 most important properties that you're going to activate a lot in chapter 3 and chapter 4. So some students prefer to memorize, but some people say don't need lah. Just do a simple substitution. Just use x plus iy, x minus iy. You can see that x or z minus z conjugate actually gives you 2 times the real part for 2x. Okay, the proof is quite easy. So these are the things that I said among the properties. These 2 are the ones that you use most often. Some people choose to memorize, some people choose to prove on the spot. I leave it to you. Can? Okay, so other than that, there are quite a whole list of properties. As I said, there are altogether 8 of them. Another one property that's a bit difficult for you guys to remember is this. Okay, number 6. Okay, this is slightly difficult to remember because we always tell you x plus, I don't know, right? Let's say I give you x plus 1 squared. Do you do this? Do you remember like this? Is x plus 1 squared equals x squared plus 1 squared? It's not, right. But then when it comes to your conjugates, this is true, no? X plus, let's say, is z plus w conjugate. Okay, it's actually z conjugate plus w conjugate. So this is a slight variation from what you're very accustomed to. So this one, half the time students cannot remember. And I don't blame you because I also cannot remember. So just prove it on the spot, actually easy. So just pay particular attention to this. Okay, so other than that, not much issue already. Okay, can you look at example 11? Is there anything wrong? Given z equals to minus 6 plus I, then part 1, what the shit is happening? Do you understand what's happening? Actually, there's a typo. What's happening? Wait a minute. What are we trying to do here? Okay. The question is actually, given that z equals to minus 6 plus I, right? Find z plus 3 conjugates. That's the question. Okay? So you just add on, given that z equals to minus 6 plus I, part 1 you're supposed to find for me or evaluate z plus 3 conjugates. Okay, so the question is actually evaluate z plus 3 conjugates. So how to do something like that? Nothing really fantastic, just replace your z by minus 6 plus I, leaving it conjugate on the outside. Then what to do next? Regroup. Real part together, imaginary part together. Then we will conjugate symbol on top, and you get the sign of the imaginary part. Okay? So far so good. Similarly, for the second one, for the part 2, z plus 3i conjugate, you can actually activate your other rule, property number 6, z conjugate plus 3i conjugate. So 3i conjugate is negative 3i, you actually get your answers. Okay? But seriously, which property you want to use, it's up to you. As long as you can give me the answer, it's okay. Any questions so far? Any questions so far for your example 11? Okay, so let's look at example 12, which is more critical. What you have now, question says find the form of x plus iy, complex number z satisfying these two equations. So just now we started off with, in fact yesterday we started off with 4 operations. Then we move up to power 1 equation, power 2 equation, read, and now we escalate one step up, simultaneous equation. Secondary school, what are the methods that you learn to solve simultaneous? 2 methods. Elimination or substitution. Of course, graphical can graph. Yeah. So we have 3 methods. So again, all 3 methods applicable under complex number scenario. So typically, forget about graph, let's talk about elimination and substitution. If I give you something like that, okay, you have z and z conjugate equation 1, equation 2. So somehow you go and do elimination or somehow you go and do substitution, the answer should appear. Make sense? Okay, so for this question, solution I have printed for you, so nothing much for you to copy. Okay, what I want you to focus on is the left-hand column first. Left-hand column. Let's run through the solution. This is your first equation that's applied to you. Z over Z conjugate equals to 305 plus 405i. Then what happens next is I I try to multiply top and bottom by z and z. Okay? Left hand side multiplied by z and z. So what happens is, I'm going to create a z square on top and a z conjugate at the bottom. Why I want to do this? Because I can pump in z conjugate to be fine. Okay? So after you do this, you're left with a power 2 equation, right? How to solve this power 2 equation? Again, it's back to your previous skill. To solve this power 2 equation, can I square it directly? Do I need to go through all this shit? See, we are here. Z squared over 5 is equal to 1 over 5, 3 plus 4i. Okay? So can I just remove the 5 and say that z squared equals 3 plus 4i? And say that z is equals to 3 plus 4i. Can or not? Can or not? Then why must I do that? Why must I do this? This basically is just to tell you can always activate and solve it by hand. If based on the setting of the question, did they restrict the use of a calculator? Never. So you can just tell me, oh, this one is square root 3 plus 4i. Press calculator, game over. I don't need to go through that. Okay? So you must always be very, very aware and alert to the setting of the question. Don't waste time doing unnecessary stuff if the question does not restrict the use of the calculator. Or if the answer happens to be, in this case, the answer is still perfect. If I change the question in the find in exact form, x plus iy, then the word exact says that you're not supposed to use calculator anymore. Okay? Take note of all these little things so that you will be efficient in the solving of your question. Okay, so this DIY one, I think I will leave it to you to do at home. You don't want to waste so much time on this thing. Okay, so the highlight of today is this section, talking about roots of equation. So back to this issue, example 13. How to solve? Don't look at your lecture notes. Z square equation, power 2 equation. How to solve? Quadratic formula. So likewise, which method you want to use? I left the thing blank for you already. Which one you want to use? Did they say cannot use calculator? No. Never. So, fine. I leave it to you how you want to solve this. Okay, always be alert to the setting of the question. Okay, GCF confirm cannot solve. Why? The coefficients are non-real. You cannot use the f. That's why I say you must understand the limitations of the calculator so that you choose the correct method. The only way is the fastest way will be your quadratic formula. But I'm not stopping you if you want to complete the square. Again, I'm not stopping you if you think that you can actually factorize it. Okay, practice. Anyone having issues? Your minus b plus minus square root of b squared minus 4ac over 2a. That is your quadratic formula. Should not be troubling you too much. Okay? So now, let me introduce to you one of the most important theorem in your complex number. This is what we call the conjugate root theorem. So what your conjugate root theorem says, this one, please box up. Asterisk, highlight this box. This is a very, very important concept. Okay, your conjugate root theorem says that if all the coefficients of your polynomial, so don't talk too complicated first. If I give you this, are all the coefficients real? z squared 3z plus 8. Are all the coefficients real? Okay. If all the coefficients are real, then what it implies is that if I tell you 1 plus I is a root to this, your conjugate root theorem tells you straight away, or implies immediately, the conjugate is also a root. That means if 1 plus I is a root, 1 minus I is a root. Can? So we read part 2 now. If all the coefficients are real, and z is a non-real root of the equation, then z conjugate is also a root to the equation. That's what your conjugate root theorem says. Can? Then our 3 equation. Are all the coefficients real? Coefficients real? So if 1 plus I is a root, who's the other root? 1 minus I. How many roots are there? What's the next root? Real or complex? Real. The next root must be real. Why? Can it be complex? Why cannot? Yeah, because your conjugate root theorem says that if 1 plus I is a root, right, automatically the conjugate must be the other root. So the third root cannot be a complex number, because if it happens to be another complex number, automatically the conjugate must also be a root, right? But I cannot afford one more root because it's power 3 only. Make sense? So this is why I say this is a very important theory. So let me run through some questions with you. I don't want to follow the lecture notes already. This one. Let's go back to square. How many roots are there? Are all the coefficients real? Does conjugate root theorem apply? So if 1 plus I is a root, do I know the other roots? How then do you find the other roots? Okay, agreed. So let me talk about possibilities now. Can I have one complex root? Can I have one real root? Possible? Can I have two complex roots? Can I have two real roots? Some people will tell me impossible because by virtue there's an I. But let's imagine I don't solve. Just by telling you the coefficients are non-real. That means I can possibly have two real. I can possibly have two complex. But the two complex is confirmed not conjugate pair. Or I can have one complex, one real. Make sense? We talk about possibilities. Of course, these possibilities can further streamline if you analyze the equation further. Can? But just assuming I just tell you like this. Can? So let's escalate to power 3. If it's a power 3 equations, analyze all coefficients real. Give me the possibilities. 3 real possible? 3 complex possible? Cannot. 2 complex, 1 real can? Yes. 1 real, 1 complex, 2 real can? Cannot. Any more possibility? No more already, right? So far so good? Possible? Possible lah, but not likely. This one possible? If it's I, possible? Alright, 2 complex, 1 real? 1 complex, 2 real? Can. Let's try because the worst I've seen in the exam so far is power 5. Come. Coefficients real? Yes. 5 real? 5 complex? No. Impossible. 4 real? 1 complex? No. Not. 4 complex, 1 real? Yes. 3 real? 2 complex? 3 complex, 2 real? Not. You can go down the line. I think more or less you got it already. You understand? Okay? So, if you can go through all this, that means you have more or less understood the theorem. Can? Okay, so let me give you some examples as to how questions can be set that activates your conjugate root theorem? Okay, so I think all these things, the blanks you can fill in on your own. As I said, I never follow the lecture notes. I just make sure that you can understand on the spot all these things. I'm asking you whether it's possible or not possible. Of course, further analysis will actually tell you that certain things are impossible. But the basic thing is that you just have to activate the conjugate root theorem to list out all the possibilities. Then study the equation further, then you can streamline some more. Okay, please remember, because up till today, the JC2s, your seniors, not the FMF students, not your FMF seniors, the H2 students, till today this thing is still not in the grade. You cannot remember it properly. Who's your civics tutor? Oh. Can I move on? Okay, so example 14. Okay, read the question first. Don't look at the solution. Read the question. Okay, what you have is that a power 3 equation. So they tell you that 1 plus 3i is a root. Okay, your job is to find the value of k. Don't look at the solution first. I know solution printed for you already. What I want you to analyze is what kind of question is this? What topic does it come from? If I give you a power 3 equation and I tell you 1 plus 3i is a root, your job is to find k. What topic is this? Factor theorem. Okay, so write down somewhere, actually this is a factor theorem question. So if it's a factor theorem question, what should you do? Substitute 1 plus 3i, replace or substitute your x by 1 plus 3i, right? Then you expand accordingly, and then you should be able to solve for k by regrouping all the real parts and imaginary parts. Make sense? Look at the question again. Before the next part, did they restrict the use of a calculator?
No.
So when you actually substitute your 1 plus 3i, you have this thing, right?
Yeah.
Can you use calculator?
Yeah.
Okay. So check how the question is being set. So don't waste unnecessary time doing all the funny calculations. Okay, so we don't want you to copy, because what happens is that when we ask you to copy, it becomes one mess of shit. So we print everything for you. But understand the logic is, substitute your x by 1 plus 3i, expand, then thereafter regroup real, imaginary. Okay? And thereafter, what you need to do is compare. The real part must be equal to 0, imaginary part must be equal to 0. So k must be equal to minus 8. So what happens? Your k is not consistent. What happens? Correct. Hong Kong or some kind of mistake somewhere. Okay? So these are the little bit of exam skills that you should have with you. Okay, so first part settled. Next, after you solve for the value of k, question now then say find the other roots. Okay, so what happens is that your equation becomes like this: 3x cubed minus 8x squared plus 34x minus 20 is equal to 0. Okay? Our 3 equation. Question asks you to find the other roots. I already know one root. Are all the coefficients real? So, via your conjugate root theorem, automatically 1 minus 3i is also a root, right? Okay. So this is the next step that I want you to know what to do next. Can I rewrite the left-hand side in factor form? So what it means is that I want you to write like that: x minus 1 plus 3i. X minus 1 minus 3i. Multiply by what?
3i.
What's the third root? Confirm real, right? Cannot be complex, right? So can I say that it's x minus away a, where a is a real number for sure. Okay? So this thing must also be equal to 0. Anybody cannot understand what I'm doing here? So the trick here is rewrite the left hand side as factors. Factor multiplied by another factor multiplied by another factor. Okay? So far so good? You understand? Anybody don't understand? But before you can write down this, the prior knowledge must come in. I run through all this with you, right? How to analyze power 3, power 4, power 5. Okay, understand that the next root confirm is a real, and understand that because coefficient real, automatically 1 minus 3i is your other root. Okay, then how? Your objective is to solve for a. Expand. How to expand? Calculator cannot use that. They say without the use of calculator. So die you must solve it by hand. So this one. Look at how I'm going to regroup it. Okay? Why I want to do this? A plus B, A minus B. Okay? But then, if you tell me you don't want to do this, you want to do your rainbow here, cannot. Cannot, just go through hell yourself. Okay, but I don't need you to go through hell. So straight away, your A square minus B square will come out. So it's x minus 1 square plus 9. Minus A equals to 0. Agree? Then, what to do next? Wait, let me see how much is printed in your lecture notes. Is everything printed for you? Okay, so fill in the 1 minus 3i, the blue section. Anything wrong with my working? Sure. Got problem no? There should be a 3 here, right? Sense? So I'm missing a 3 here. You understand? Can? So far so good. What to do next? Okay, so if you actually expand, you're going to have x squared minus 2x plus 10 coming out. Okay, so this one becomes x squared minus 2x plus 10. And then this is 3x minus 8. Agree?
Three should be outside.
Can 3 be inside or outside? Wait. I don't want to follow that method. Anything wrong if I write this?
Then the B is not the solution.
Then A is not the solution.
The solution is
Yeah, A over 3, it's fine.
Yeah.
As long as you can understand. As long as you can understand. Can. But why I want to go through this method with you is, okay, let's look at this first before I look at what you see on the board. Okay? What I want to check right now is, by looking at what you have here, can you tell me what is A immediately? What's A? Without expansion, without long division.
Yeah, like keep it constant.
Yeah. Because the constant term will be minus 10a, right? Minus 10a must be equivalent to minus 20. So your A is 2. So 3x minus 2 comes out, right? So from here, who is the next root? Yeah. So from here you must tell me x is equal to 2 over 3. If you do it my way. But if you follow the lecture notes method, they take out the 3. So your alpha straight away will be 2 over 3 immediately. Same logic. Okay. So how you want to solve this kind of equation, I leave it to you. But important thing is, when you actually write down in terms of factor form, you must always be a little bit more observant how your things play out, especially when there's a coefficient in front of your highest power term. Yep.
Why don't you just do partial expansion in the step? Like it's A times bracket 1 plus 3i bracket 1 minus 3i and equals to
Also can. how you actually arrive at the next root, seriously, I don't care one. No. Some people will tell me, oh, I want to do long division. Anything wrong? Nothing wrong. It's just a matter of choice. So end of the day, how you arrive at the answer is none of my business. The whole objective is efficient and fast, and make sure it's correct. Okay? So all the possibilities in pertaining to solving this, I leave it to you. So some people even worse. Okay? So what will happen if you don't understand your conjugate root theorem? What will happen to some students is they will do something like that. Oh, 1 plus 3i is a root, right? So they will tell you x minus 1 plus 3i followed by ax squared plus bx plus c equals 0. Correct or wrong? All I know is 1 plus 3i is a root, right? So x minus this multiplied by ax squared plus bx plus c. Correct or wrong?
Correct.
Correct, right? Still correct. Just that you're just wasting your own time, right? Correct? There's nothing wrong. So students who actually forgotten the conjugate root theorem, they'll go through this stupid thing. But then you go and expand, compare. Walao eh. You're working from a 5-line working become a 2-page working. You want to do that? So it's up to you. Hence, so let's repeat everything again. How you arrive at the answer, seriously, I don't give a damn. As long as you give me the answer in the correct way, in the most efficient way, don't self-penalize yourself, we are fine with it. Okay? So far so good. Okay, so you see the lecture notes. I give you conjugate root theorem. Then after that, I actually activate the stupid 工厂 down here, and you're going to try. Walao, stupid, don't waste time. Can? Any issues? So the other thing here that we are quite worried, especially not for you all actually, is more for the H2 students, but for you guys you better be more precise. 1 plus 3i versus x minus 1 plus 3i. 1 plus 3i is a root to your equation. X minus 1 plus 3i is a factor to the equation. That's all. Use the correct terminology, especially for you people, because what you're going to get in your A-level exam will be, if this kind of question won't come out for further math. Okay, so if I actually want to set something like this, I'll be very precise or very particular on how you actually term your stuff, so that you know how to handle the questions that is of higher level. Can? My time is almost up already, right? Yeah. Are we done with this chapter?
Yeah.
Okay, so congratulations, we are done with this chapter.